All right, good morning, everyone, and welcome. We have a very special workshop for you today by Giuseppe D'Angelo called Back to Basics, Writing a Model. Just a moment. Let's see. We see some people coming in. All right. Hi, everyone. Good morning. Good morning. Hello. Welcome, everyone. Happy to have you here at QtDay. Okay, fantastic. So we're going to do a workshop today, back to basics, writing a model. And let me go ahead and introduce you all to our workshop speaker today, Giuseppe. Let me bring him live for this part. Here we go. Hi, Giuseppe. Glad to have you here.
Thank you. Good morning, everyone.
Good morning. So before we get started, I'm just going to tell them all about you a little bit. So Giuseppe here is an improver of the Qt project and a software engineer at KDAB. He is a longtime contributor to Qt, having used Qt and C++ since 2000. His contributions in Qt range from containers and regular expressions to GUI, widgets, and OpenGL. A free software passionate and Unix specialist. Before joining KDAB, Giuseppe organized conferences on open source around Italy. He holds a bachelor's in computer science. And about our workshop today, in 2020, let's go back to basics. Writing model and view code. It's somehow taken for granted. It's, however, a mandatory skill for any proficient Qt developer. Professionals are supposed to be able to write robust, fast, and tested models. And so we'll see how to do that together in this workshop. And any non-trivial Qt application will feature usages of the model, view, controller framework, and MVC is a well-known design pattern embracing separation of concerns between managing the data and the user interface that is supposed to visualize and manipulate it. So what exactly is a model in Qt's MVC design? How do we write one? What is the developer's responsibility? And what instead is provided by Qt, maybe as convenience? What are the performance characteristics of the models, and how do we test one? So the answers are not so trivial, and it's important to nail them down to write robust model code that will drive the rest of our user interface. So in this workshop, we'll write together some models, use them in combination with some other views, and while doing so, show all the best practices associated with such development. All right, so I hope you all enjoy. We'll have a short video and then get started. So talk to you soon.
Okay, here we are. Let me just get started and share the presentation slides. Okay, that's very good. Fantastic. All right. So once more, good morning, everyone. Thank you very much for the kind introduction to myself and to the workshop. This was actually the subject of the first couple of slides I had here. Regarding presenting myself, I'm kind of an old-timer here at QtDay. So I work for KDAB, and I write a lot of code related to Qt. So I decided this year not to talk about something new, something bleeding edge, something that is coming with Qt 6. I decided to slightly go back a little bit and decide to focus on something that I find foundational. And the thing I found foundational this year was writing model view code. Why is that? Why is that important to me? Why is it kind of code got this special place in my heart? Well, because I think that as someone who uses Qt every day, it's extremely important to understand what are the basic foundations of Qt programming. Because the basic stuff, it's used literally everywhere, even more than the bleeding edge stuff. Maybe you're not running Qt 6, maybe you're not even running Qt 5.15. So there is something about let's focus on something which is there, which has been there for a very long time, and I don't believe it should be ignored. I believe that this stuff needs to be discussed more and taught more and even improved. And although what I'm going to talk to you about today is model view programming, and model view programming is a very old thing in Qt, it does not mean that being old is somehow perfect and there's nothing to improve there, there's nothing to not learn. No, there is a lot to learn regarding the basics. There are still some rough edges around Qt, and there is still some evolution happening. Even in Qt 6, we're adding new stuff into model view programming. So why specifically I decided to talk about the model view is because model view is a central framework inside of Qt. Something that I always say when I give this kind of trainings and I give this kind of workshops is that any non-trivial Qt application will use some model view. And some application actually uses model view extensively. Okay, in any application you're going to write using Qt, there is going to be something which is a list of things, or a table of things, or a tree of things. And these will be data-driven. So you may have, whatever, a list of Wi-Fi networks somewhere, right? That you gather somehow, and then you need to show it in your UI. So if you're a developer and using Qt, maybe you may not end up writing view code. Maybe you will have designers handling the presentation part of this data. But as a developer, you will write models. You will write lots of models. So it's, I believe, important to master this. This should be like not an acquired skill anymore. It should become part of your daily life using Qt. You should not be afraid of writing one extra model if you need that. So what are we going to see today? I've prepared a little agenda. So the first part of this workshop, we are going to introduce a little bit of theory. So what is all about model view programming in Qt. I will start really from the foundational parts. I will start with the definitions and the basic concepts. What is a model in Qt? That is a good question. We need to answer that question. What is a view? What are the responsibilities of the model? What are the responsibilities of the view? And then we will focus exclusively on the model part of things. So what is the structure of a model in Qt? What kind of data can be represented by a model? And how do we access this data into a model? This will naturally go into discussing the base class of all models, which is this class called the QAbstract item model. We will have an overview over its API. And then we'll switch into kind of a hands-on part. So I will do some live coding. Yes, I will risk my career on this. And we will actually together create a list model, which is the simplest model that we can create. But that will actually make us learn a lot about model design. Because lots of things that we're going to see in there actually apply also to other kind of models. So we will spend quite some time creating one, refining one, trying to understand what are all the implications of its API. And in its first iteration, we were going to just create one which is like read-only. And then we will change it to one which is actually modifiable somehow. So we will see how we can handle modifications of the model data. And then time permitting, we can see how these can evolve into something more complex. So stuff like a table model or a tree model or other more complicated model concepts. Okay, so I've got some slides at the end, time permitting. So without further ado, let's get cracking and let's start discussing the very basic steps about model view programming in Qt. Okay, so What are our goals for now? Our goals for now is, if you want, definitions. We want to understand, I've used the word model a lot, but what is a model exactly? What is a view exactly? If you ever encountered model view APIs in Qt, you may also wonder, what is a delegate? And if you have used model view in other frameworks than Qt, sometimes this pattern is not called model view delegate, it's called the model view controller. So what is the controller thing, right? What is that, and how do I use it? So let's start by defining what a model is and what it does, okay? A model in Qt is better thought as a class which functions as an adapter class. An adapter between two words, between two sides. On one side, the job of your model is to access some data. So you have some data somewhere. I'm going to discuss in more detail what it is this data about, but you have some data that you want to access. And the job of the model is to access this data. And that's one side of things. On the other side, the model exposes this data using a standard unified API, which is the API of this class in Qt called QAbstractItemModel. Okay, so it really functions as, if you want, an adapter, something that takes data which is customized, can have different shapes, different forms, and exposes it in a unified way. Okay, what's the idea of having such an adapter? The idea is that once I have a model, once I have such an adapter, then the upper layers, typically the views, can simply target the QAbstractItemModel API. And therefore, they can completely ignore the underlying details about how the data is actually accessed, because these details are completely encapsulated by your model. So if I have to represent this graphically, I would probably use something like this. Okay, so you have your data on the bottom. That's your data. You only know how to access it. On the middle, we have a model, which is a QAbstractItemModel subclass, something that we are going to write in a short while. And on the top, you have something that uses this model somehow. Okay, so you may have, for instance, if you're writing a widgets application, you may have a widget view that shows the data in the model. If you're using Qt Quick, you may have a Qt Quick view that shows the data in the model. But perhaps you may also not have a view directly. You may have some other C++ component that gathers the data through your model. So you may have some piece of logic that analyzes the data, that filters the data, that does something with it, okay? And it knows how to do that because it simply uses your model as a QAbstractItemModel. So it implements the API that is required. Okay, so this is what a model is. And I believe it's extremely helpful to think of its responsibility like this, okay, as this intermediate layer between the actual data and, generally speaking, the views. What is a view? So I've just mentioned them. Let's define them. A view is a graphical component of some sorts that displays the contents of a model. Okay, so it's a widget if we're using Qt Widgets, or it's an element, a component if we're using Qt Quick. And the job of a view is to display the contents of a model. So when we use Qt, Qt actually ships with many built-in views in Widgets and Qt Quick that we can just grab and use because they just work. I have a couple of slides here just to give you an overview of what kind of views you get out of the box when you use Qt. So if you're using widgets, because maybe you're writing a desktop application, the views that you're likely going to use are one of these three. We have a so-called QList view, which is a widget that simply shows a list of elements, like here on the right. We may have a tree view, a QTree view to say it all, which is the one in the middle. And as you can see, this actually shows a tree-like structure. And also has several columns. Okay, so this now looks like a file manager of some sort. And then we have a QTable view. And a QTable view is a table which looks like a spreadsheet if you want. It's the one on the bottom looks like a little bit like Excel or something like that. There's also some other, but they are really seldomly used, so I'm not even going to mention them. These three are by far the most common ones. If you said you're using QtQuick, you also have views in there. So if you're using QtQuick, you may have something like a list view, the one on top, that simply arranges the elements in a list. You may have a grid view, the one in the middle, arranges the elements in a grid. You may have a path view, which arranges elements across a path, like this one on the bottom. You may also decide to use a repeater, which is a special QtQuick component that gets a model and simply creates a number of objects out of that model. And typically, these gets combined with something to position the elements, something like a row or a column. Those are elements in QtQuick that allow you to lay out the objects created by the repeater. Okay, so a view is just this. It's something that gets used to visualize the contents of a model. We create one of these and we show it, and that's it. We're good to go. Oh, sorry. Yeah, in QtQuick, I believe in 5.14 or something like that, 5.12, we also have a table view now. And on the Qt Marketplace, there is now also a tree view element. Okay, so this shows like a table, and this shows like a tree. Yep. So there is something important to say about views in Qt, at least. The idea about a view in Qt is that the views read the data from the model, but they don't actually display the data themselves. They don't display the data directly. The view, the main purpose of a view is actually to lay out other objects that we're going to call delegates. And these other objects are laid out, of course, according to the kind of view we're using. So if you're using a list view, then we lay the delegates one below each other, right, vertically. If we're using a table view, then we actually have a two-dimensional grid of delegates. And what is the point of this other object? Well, the point of a delegate is actually having an object whose responsibility is to draw, to edit, and to interact with one single piece of data. Okay, so if to represent this graphically and to understand the different responsibilities between a delegate and a view, suppose I have this list view here represented in the middle. Okay, so a list view as a whole has an overall idea of a view over the model. So what it needs to do is to, for instance, provide scrolling, provide an idea of having selection or a current item. Okay, but a list view itself does not actually draw any of these lines. The lines themselves are drawn by something else, something that we're going to call a delegate. And the responsibility of a list view is simply to lay out these delegates, since it's a list view, vertically. Okay, and then it tells the delegate, draw the first element, draw the second element, draw the third element in this position. That's what a list view does. There are some minor differences between how this works in QWidgets and in QtQuick, but the theory is pretty much the same. So regarding views and delegates, there is something to say here. When we use Qt model view, we typically don't create views in the sense that we don't create our own customized view. We just use the ones that come with by Qt, right? So if Qt provides a list view, we're just going to use a list view element. We create one and we go with it. But we don't create a brand new view, a new view class, that should I say. The reason is that typically we don't need any of that, okay? However, sometimes we may need to customize the look and feel of the elements inside a view. And for doing that, sometimes we're going to create a custom delegate and set it on the view. When do we do that? When do we create custom delegates? This depends. So if we're using Qt widgets, there are actually built-in delegates that just work. Okay, I can create something like a Q list view, as I'm going to do in a second, and I just show it, and the Q list view actually shows something on the screen. In Qt we are not so lucky in the sense that if I'm using Qt and I create something like a list view in Qt does not have a built-in delegate, and we must write one ourselves. So we must write some code which is responsible for dealing with the drawing and interaction with each line inside a list view. Okay. Qt Controls True has some delegates that we may decide to just use, but those are not in Qt, they're in this controls library. By all means, use them as starting points if you want, but then Qt sometimes requires us to actually write our own delegates. Okay, but this is not the focus of today. The focus of today is writing models, not delegates. Okay. And what about the controller? So if you're coming from another framework, you may wonder, where is the controller? Well, there isn't a controller as traditionally, as is intended traditionally in the Qt model view framework. The traditional responsibilities of a controller are a bit split between the view and the delegate itself. But that's fine. It's just a matter of terminology. It's just a matter of understanding who does what in Qt. Okay, and this diagram on the right should make it clear about who does what. Okay. So to summarize this little bit of theory, we have three things. We have one, models. Models are just adapters for the data. Number two, we have views. Okay, and the point of a view is to display a model. Number three, we have delegates. Okay, delegates are objects which are sometimes created, destroyed, but especially laid out by views. And the purpose of a delegate is to draw one single unit of data and to manage the interaction with that unit of data. Okay, that should be fine. So let me actually show some of this in action if I manage to share my screen, and voila, and switch back to Qt Creator. So we can actually see a little bit of this theory practically done in practice. So what I have here is a little application that creates a model right here on line 34. I'm creating this simple model called the QString list model, and I'm populating it with some color names. And then I'm creating two different views to showcase that model. The first view is created right here, line 37, in which I'm creating a Q list view. So that's a Q widget view. I'm setting this model on it, and I'm showing it. Okay, these are these three lines. I'm also using the same identical model in Qt. So in order to use this model in Qt, I'm doing something else, which is, first and foremost, I'm exposing my model using in Qt. So this is not a Qt course, but if you want to know more, please Google this when you have some time. This is a way to expose my list model object in QML. And then down here, I'm going to actually load some QML and show it. So what is inside this main QML? Well, let's find out. So inside that main QML, I have now a Qt list view. Okay, that's a list view. So it's a Qt component. Its model is going to be my model coming from C++. So it's the same list of strings. And in Qt, I also have to specify this object called a delegate, which is responsible for drawing each line inside my list view. So let's say that I want each line to be like a rectangle whose color is alternating. And inside that rectangle, I got something else. I got some text. I got some other elements. This is all I need to write manually, or sometimes my designer writes this for me because I'm not that good at actually writing UIs. But this is required for list view to actually show something on the screen, because list view in Qt does not come with a built-in delegate. If I run this, I end up with these two views showing the same model. So on the left, I have my list widget, it's a Q list view. It's a widget coming. And on the right, I got a list view in QML. Okay, you can see this QML. It's got all this fancy kinetic scrolling and whatnot. Okay, and I had to specify exactly how to draw each and every line. But the contents of these two views are actually the same. They both feed from the same model. So as you can see, there are the same names in both lists. Okay. All right, back to the slides. Here we go. So that's a little bit of theory about model writing. Now let's go more in detail and focus on what is a model exactly and how does it look like? What is the structure of a model? Okay. So I'll go back to this slide and let's remind ourselves once more, what is the responsibility of a model? Okay. The responsibility of a model is to access the data, and you know the data, you know what the data looks like, okay? And expose this data to views and to other consumers, to anything you want, using the QAbstract item model public API. That's the responsibility of the model. So what do I mean by data? I keep using this word. What is data, data, data? Okay, so the data itself can really be anything you want, or almost anything you want. The data is something which is specific to your application, and it can be something that you use in your business logic. Okay, so it could be something like an in-memory data structure, like a vector of objects that you want to represent in some view. Maybe a tree of objects, a tree of nodes, who knows? It could be not in memory. Maybe it's on disk, the contents of some file that you have, and you want to represent it into a view. Maybe it's not even in a file. Maybe it's like metadata. For instance, the file system structure below a given directory. So you got like a root directory, and inside that directory you have files, and you have subdirectories, which also have files inside. Okay, this is kind of metadata of the file system. It may not even be local. Maybe you want to represent the contents of a table in a SQL database elsewhere, or maybe the results of some SQL query. That's fine. You can represent this inside a Qt model view. Maybe the result of a REST call to some cloud service. Okay, this doesn't matter for us. Oh, this doesn't matter for Qt. Why does it not matter for Qt? Because as the author of your models, you know how to actually access the data. You know what kind of library you have to use. You know what kind of SQL queries you have to run in order to access the data. That's the responsibility of your model. And that's what you need to do. So inside your model, you're supposed to write any sort of glue code, which is required to access your data and present it to the views using the QAbstract item model API. Now, I said almost anything. Why almost anything? Well, because typically in a user interface, we don't actually have like arbitrary data visualized. Qt models are able to show and to describe these kind of data structures, and only these kind of data structures. That is, Qt models are able to describe things like lists of elements. So if you want one-dimensionals, things that just have rows, they are able to represent tables of data. So two-dimensionals, you have rows and you have columns, and also trees of elements. So you have rows, you have columns, but also at each level you may have further children down. All right, Qt models can describe these because these are the ones that you actually have typically in your user interface. Some other fancy data structure, like, I don't know, a graph or something like that, sorry, that's not so common. You don't represent it using QAbstract item model. You need something else. Okay, now let's look at this picture on the right. Right, so you see the tree, and that looks like a tree. Yes, it's got a root, it's got some rows. The first row also has children and whatnot. But let's move a little bit to the left. Let's look at the table. So the table, yes, it's rows, it's got columns, but it's also got this strange root item over there, which does not really belong to a table, does it? And also a list. I mean, yeah, I got individual rows, and also the list it's got this root item. What's the deal with that? Well, the deal with that is pretty simple. For Qt, lists and tables are actually special cases of trees. So they are just trees without children, without further children. So a table is just a tree without children, just the first layer, and a list is actually a table with one column, just the first column. Okay, these are considered, if you want, special cases of the most general case, which is the tree model. Why does this matter? Why do we care? That's because this kind of a structure is present in the QAbstract item model APIs. So when we use the QAbstract item model APIs, we will see that everything works thinking of trees. Even if we don't have a tree, even if we just have a list, we are constantly reminded that things are derived from this more generic data structure, which is the tree, even if we are in a simpler case. Okay, so let's start delving a little bit more in depth about how do we access the data inside a model. Okay, I got a model. It may be a list, maybe a tree, maybe a table. How do I actually navigate into it? So the first class that we need to discuss in order to understand that is a helper class that we use in order to navigate our model. This helper class is called a QModelindex. Okay, and what is a QModelindex? A QModelindex is, if you want, a pointer, double quote pointer, pointing to a specific position inside a model, pointing to a specific cell into a model. So what we can do in order to access the data, what we must do in order to access the data is, first and foremost, obtaining a model index pointing to a specific piece of data, to a specific row, to a specific column. Okay, that will be the first step. And then, given a model index, we will actually be able to access the data. So how do I actually do that? How do I get a model index from a model? Well, it works like this, okay? And it's, again, less obvious than it needs to be because everything is done in terms of trees. So the first thing that we can do is obtaining a model index pointing to that root item that every model has, even non-trees. I keep insisting on this, okay? So if I have this table model here on the right, okay, the first thing I may want to do is to get a model index pointing to the root item of the table model. And getting a model index pointing to there is extremely simple. All I need to do is default construct a model index. So if I write QModelindex parentheses, okay, what I get is a model index that represents the root item of the model. Okay, this root item over here is obtained by simply creating a default constructed model index. Now, I wish that once you do that, I wish that once you write QModelindex, that model index is called a root model index or something like that. That is not the case, unfortunately. For some reason, like lost in history, the model index that represents the root item is simply classified as the non-valid or invalid model index. Okay. And in fact, if I have a model index and I want to know if that model index is pointing to the root or it's pointing somewhere else, the call that I have to do to distinguish these two cases is called isValid. Okay. The usual joke at this point is that if I had a time machine, I could go back when this thing was designed. I probably would not name this as isValid. I would probably call this like isRoot or something like that. But that's what we have. So isValid, consider these in your mental model that if you have a valid model index, it means it's pointing somewhere in the contents. If you have a non-valid model index, then it's pointing at the root. That's the mental model that we should have. Okay. So default constructed model index points at the root. Fair enough. How do I get into the table now. So the way I get a model index pointing somewhere into the table is by using the index method on the model. Each model has to provide this index method, okay, which returns a QModelindex pointing to a specific position. Now, this index call takes 3 parameters. It takes the row that you're interested in, the column that you want, and also, of course, the parent index. Okay, so the index of the parent element relative to the one that you're asking for. So suppose we want to ask about A. I want the model index to point to A. How do I get that? Well, A is at row 0, column 0, and what is its parent? Its parent index is the root. So its parent index is the invalid model index, the non-valid model index. Okay, so a way to ask for the index of A is getting my model and asking for index, row 0, column 0, below the root. Okay, remember what this means. The invalid model index means the root. To get an index for B, this is now row 1, column 1, again below the root. So 1, 1, QModelindex, open and close parentheses. And C is row 2, column 1, below the root. Row 2, column 1, below the root. Yep. So this is what I meant when I said that the fact that even a table is a tree appears in the API. You have this third parameter around, which does not make any sense in case of tables, but it's still there, right? And you need to know that it's there and what it means. Let's actually make it to good use. Let's see another example of getting an index pointing to somewhere, but this time if we have a tree. So if I actually have a tree model, now this parent parameter becomes actually meaningful. So suppose I want to get the index for B. Okay, how do I get the index for B, which is down here? In order to get the index for B, I need to ask for row 1, column 0, below A. But wait a minute, I don't have the index for A. Right, you need to go one step further. So first you need to ask for the index of A. What is A? A is row 0, column 0, below the root. Okay, I can do that. That's the first line. The index of A is index 0, 0, below the root. And once I have the index of A, I can actually ask for the index of B. So what I do is that ask for the row 1, column 0, below A. Okay. So the third parameter now, the parent index, can be meaningful. It's not always the default constructed one. In trees, it's different. Okay. So now I know how to build one. Let me discuss briefly the API of a model index. So if I give a QModelindex with an index, you can actually ask a few questions about it, because a model index has somehow a little bit of awareness regarding its position in the model. Given an index, you can ask it, what is your row? What is your column? What is the parent index? So if you're a valid index, what is your parent? This might be the root. This may be something else. Are you the root? Is valid? Think of it this way. Think of it as a query for asking, are you the root index or not? Okay. If you're valid, you're not the root. If you are not valid, you are the root. And what is your model? Where do you come from? I mean, what model created you? You can ask all these questions to a model index. Okay. Now, there's one important thing that deserves one slide regarding a model indexes. So now we know how to get them. But there is one important note, which is this. Given a model index as an object is meant to be created using the index call that we have just seen, use it to access a model, okay, and then immediately discarded. You're not supposed to store model indexes. The reason is that, remember I used the word, there are pointers, double quote, into a model. Well, yes, just like pointers, they may become dangling. They may become pointing to illegal data. So you're not supposed to keep them around for longer than strictly necessary. Sometimes you may have the need to actually keep some of these for longer, and if you need something like that, then please do not use a QModelindex. Use another class, which is very similar. It's called a QPersistent model index. The difference between the two is that a QPersistent model index does not become dangling like a QModelindex might. And of course, there is a trade-off in the other direction. Using a QPersistent model index is much more expensive than using a plain QModelindex. So you shouldn't just use persistent indexes just because. You should know when to use them. To give you an idea of a possible use case, a QPersistent model index is used, for instance, if you need to track which one is the selected item into a model. Okay, so you have a model and you want to know that the fifth element is the selected one, and you need to keep track of that somewhere. What happens if the model is modified later and maybe you remove the first row? Then, of course, the fifth element becomes now the fourth, but it's the same element. I need to remember that it's the same element that is simply moved. Okay, so the point of a QPersistent model index is that it will follow the element as it moves through the model because the model has been changed. A QModelindex will not follow it, and you will likely crash or access the wrong data, all sorts of bad things. Okay. Now, let's use a model index to actually access data. How do we do that? There is one extra thing to know before we can actually jump and access data. That is, each cell inside a model can provide multiple data. Model view in Qt, a model view in Qt can provide, if you want, different aspects of the data which is required to represent one single cell. So let's look at what I have right here. Okay, this is a list of elements if you want. Okay. But each element has multiple things that are shown. There is a string which is shown here on the right. There is also a color next to it. Okay, and if you overlay your mouse cursor over it and wait for a tooltip to appear, there is also a tooltip that appears. And as you can see, it does not even contain the same data which is shown in the model. It contains some other data. Okay, so for each cell, for each index in the model may provide different data. And how do you distinguish these pieces of data? The way we distinguish them is because each different piece of data has a so-called different role. Okay, different roles are used to identify different, if you want, use cases for the data that I'm requesting from your model. There are some roles that are provided by Qt. They have, like, if you want, built-in meanings, but you can always provide your own roles in case you need something like that. So to give you an idea, if I have a model and ask to this particular cell for its so-called Qt display role, the model is supposed to return the string to display. So in this case, red, as a string, okay, with uppercase R. If instead I ask for the decoration role, that's another piece of information. And typically the decoration role is supposed to return a color or a pixmap or an icon, which then gets used to draw the decoration next to my text. Okay. And there are many others. If you open the documentation for Qt item data role, I might do it later. That documentation will tell you that Qt defines some like 15, 20, couple dozens of built-in roles with built-in semantics like this. Okay, but the actual role is just an integer. You are free to define your own role with your own special meaning if you need to return data from the model that has a special meaning to you. Okay, and now we are ready. Now I got an index and I know which role I want to fetch data from. I can actually go to the model and request some data. And the way we request some data from the model is by calling the data function. So I have my model, I call data, and data takes two parameters. It takes an index and takes the role that I want the data from. Okay. I want to focus on this first line because this makes sense, right? But what is the return type of data? I mean, data has to return a string if I ask for a string. It has to return a color if I ask for the decoration. So if I ask for the color there, how can the same function return multiple data types? Well, say hello to my little friend. In Qt, we have this so-called QVariant type, which is a generic container for types. Okay, inside a QVariant, you can store any type that you want. You can store strings, you can store icons, you can store pixmaps, you can store colors, and pretty much anything you want can be stored into a variant. So model data actually returns a variant. It does not return something else, okay? So suppose that I want to ask for the text. Suppose that I want to ask for the display role of this cell right here. I got the index, and what I need to ask is model data, display role, and this returns a variant. So then I need to extract the string out of the variant, and the way I extract the string out of the variant is by calling toString on the variant. But through the same mechanism, you can return custom data types. QVariant is actually extensible. You can add support for your own data types inside QVariant. So it is legal to ask your model that index and your specific role and return some specific data here. Okay. Once you do that, I mean, if you have specific roles, typically the built-in delegates don't know what to do with your role, but you can always write a delegate that also knows how to handle these in a special way. Okay, so to summarize, this is a little bit of theory so far. By using Qt classes, by using Qt model classes, such as QAbstractItemModel, okay, we can describe lists, we can describe tables, we can describe trees. A QModelindex is used to identify one element in the model, okay? And a non-valid QModelindex is used to represent the root element, right? And remember that even lists and tables have roots because they are seen as specialized cases of trees. Now, a model is composed of cells, it's composed by different elements, and each element can provide multiple data under different roles. Yep, and we've seen why and how. So, by the way, it's time for, if there are a few pending questions, by all means, please ask them in the chat or in the Q&A room. So feel free to interrupt me at any time. I will, from time to time, keep an eye on the chat and reply to anything that that is happening in there. I don't see much activity, so I'll just probably continue a little bit, then we have a short break. Let's start with an overview over the API of QAbstractItemModel. So let's see what a model can do and what a model is supposed to do. The reason why I want to do with this overview and over the QAbstractItemModel API is because then we are going to actually implement some of these functions in order to create our custom model. Okay, so as a broad API, what does QAbstractItemModel need to do in regarding to the views, regarding to the upper layers? QAbstractItemModel needs to describe what is the structure of your model. And by that, I mean things like how many rows do you have? How many columns do you have? Stuff like that. It needs to provide the contents of the model, as we have just seen, through the data. And also, models are not necessarily static. Models may change over time, okay? So when a model changes, it must notify the views that something has changed so that the views have a chance to update themselves. And therefore, the QAbstractItemModel API also has change notifications, okay, that we must implement. There is also something else about this, that is views sometimes may want themselves to change data into a model. Maybe you want a model which is editable from a view. So there is also a writing API, not just a reading API, that allows a view to change the data contents or change a model structure. Maybe you want to rearrange rows or something like that. Okay. So let's have a quick glance, a quick overview about the APIs of QAbstract Data Model. The first thing, which is also the first thing that we're going to encounter, is there is a number of functions that we have to implement in order to describe our model structure to the views. Views may ask, how many rows are inside your model? And how many columns? And actually, how many rows do you have at each level? Because maybe you have a tree, and the rows below the first child are not the same rows below the second child, right? So this query is slightly more complex than just asking how many rows do you have. But anyhow, you have these functions called like row count or column count or has children and so on that views may use to query, to ask information about your model. You also have the index and the parent calls that allow a view to get an index to a specific element. So a view asks you, how many rows have you got? 5. Okay, give me the index for row number 3. Here's the index. Okay, this is part of the scheme between describing a model to the view. Then, of course, a view can ask, what is the data at one specific index? Okay, because I want to draw it, so I need to ask for the data. We have seen the call that that views use to ask for the data is actually called literally data. In Qt6, this is also augmented by another function called multidata, which allows a view to ask for multiple data in one go, for multiple rows in one go. There is also something extra. For instance, some views display headers on the top or on the side. So this information is also provided by the model to the views. And almost finally, there is also something else related to notifying views regarding changes into the model. So if something changes into the model has to tell the view, hey, this is happening, please update yourself. And models have like 20 or something like that, different signals to do this notification mechanism. So they can tell the view, hey, look, some data has changed inside my model. Or, hey, look, some rows have been inserted inside my model. You need to refresh yourself. You need to update the scrolling position, right? There's plenty of these signals, and we're going to see how to use them. Also, views may want to modify the data inside your model. So, excuse me. So optionally, you also have to implement functions like set data or set header data if you want a view to change the data inside your model. And finally, you may also want to let a view modify the structure of your model. For instance, by moving a row from somewhere to somewhere else. Okay. What is the moral lesson of all of this? Why did I list all of this? Well, because the actual overall API of QAbstract Data Model is huge. If you look at the documentation and you look how many virtual functions are inside QAbstract Data Model, there is plenty of them, dozens of them. Okay. Now, don't get scared about these. Okay. Most of those are not pure virtuals. Okay, most of those are not abstract. Most of those have a default implementation that does nothing at all. Okay, you're not required to implement them. So most of this API is actually optional. Maybe your model does not need to be modified by view. Ignore the setters. Don't bother with them. And there is even something extra on top of this. That is, there are convenience subclasses of QAbstract Data Model for some common tasks, right? And we are supposed to use them because they will simplify our implementation. For instance, if you're implementing a list or if you're implementing a table, as we are going to do, we are going to use these convenience subclasses that implement something for us. And inside Qt, there are actually concrete classes that sometimes are useful if I just need a model somewhere and I don't want to implement it myself. I just want to use one coming from Qt. So just a quick word about these helper classes, about these convenience classes. If we are implementing a list model or a table model, we are supposed to use the convenience. We are supposed to use QAbstract list model and QAbstract table model. Right? These two are subclasses of QAbstract item model. Okay, and they simply have already some implementation of some methods for handling lists and handling tables. Okay? So most of the mandatory part is still implemented. There are just a couple of virtuals that we need to implement in these two. And of course, we can still implement all the optional parts. So stuff like support for modifications. If I need a modifiable list model, I'm going to subclass QAbstract list model and implement just the reminder of the methods to handle notifications. And to quickly see also to say something about concrete models, so concrete model classes. In Qt, there is some classes that we may just decide to use as is. Stuff like a QString list model. This is a ready-made model that simply exposes a list of strings. Now, is this really useful? Maybe for prototyping. Yes, it's really useful. I have got some view. I want to put some contents in there. I don't have the model, the actual model yet. Let's just populate it with a string list model. Maybe a generalization of this is something called a Q standard item model. Now, this is a complete misnomer because there is nothing standard about it. You're not required to use it at all. This standard, forget about it. It's really, I don't know why it's called like that. A Q standard item model is simply a model, which can be a list, it can be a table, it can be a tree, and it's a model that you build in program code. You create one of these objects, and then you say, okay, please add 10 rows to yourself, and it will add 10 rows. Okay, and then you say, set the data of the first row to this, and it sets the data of the first row to whatever you want. Okay, so this is also useful for prototyping or something like that. But there are actually good models that are useful, something like Q file system model. This is a model that represents the file system structure. Okay, so if you have to just visualize some folder structure, then don't create the model yourself. That's extremely tricky. Just use Q file system model. In the Qt SQL module, there is also something called a QSQL query model and also QSQL table model. This can be used to represent the result of a SQL query. Okay, and there's even many more available elsewhere. So in our KD Toolbox library on GitHub, or in KDE, in K8 item models, you got ready-made models to show data. So you don't need to implement a model yourself. Okay. So we're almost 1 hour in. I would say, there are any questions? Let me check. Not yet. Shall we take just 5 minutes break so I can get some water to drink? And we will be right back. And we actually turn this into hands-on. This is a workshop. So I'm going to create a list model live and see what does it involve.
Sounds good. All right, everyone. As you heard him, we'll have a 5-minute break. So it's 59 now, and we'll see you at 4 past the hour. Have a good break.
Sounds good. Thank you.
Thanks. All right, everyone, welcome back from the break. It's been about 5 minutes. Hopefully you got some coffee or a bit of water and are ready to go back. So let's go ahead and bring Giuseppe back so he can come here. And also I wanted to say, hi, welcome back.
Hello.
I see that you have a question here from Daniele, if you wanted to answer that.
Yeah, I managed to scroll the chat and... Okay, so the question is, what about performances of models? Can I have a huge amount of data within a model layer on top of it to let a view display items? Yes, you can have a huge amount of data within a model. Remember that the data is not inside the model, right? The data is somewhere, and you can have a big data structure somewhere, and the model simply is supposed to adapt that data structure for the purposes of a view. So yes, it can be as big as you need. Of course, well, we're actually going to show this right now, but views don't ask for the entirety of the contents of a model. Views are smarter than that. They typically just request what you can see on the screen at any given time, plus or minus a little buffer, but that's not important really. But by all means, they don't ask for the entire contents of the model to be fetched just to show 3 lines. That would make no sense. And also another part of the same question, what about single notification of, let's say, 1,000 cells, each of which can change every 30 milliseconds? That is also perfectly possible, yes. There should be no major concerns. Of course, as I say that, the rule of thumb is, of course, profile. Don't give anything for granted, and don't assume that the bottleneck is somewhere without measuring it first. But that is not absolutely a problem. You can have many notifications per second, really, even many more than you're saying right here, right now. 1,000 of notifications every 30 milliseconds, that is perfectly doable. As I'm going to show in a second, actually, you could do better than that, in the sense that the notification that some cells have changed, you can either emit them, if you want, atomically, one cell by one cell, but you could also submit them in batches. The actual notification takes a range. It does not take just the individual cell. So you may actually optimize that out and say, this block of 1,000 cells has changed, not this cell and this cell and this cell and this cell, emitting then 1,000 different notifications. I don't know if that answered the question, but please, if you have further questions, let's keep them coming. And I will continue now. If I manage to go back to the slides. Yep, here we go. By asking, how about creating a list model? So it may sound simple, but this allows us to actually explore all these different aspects of creating a model. How do we go about it? Okay, and what are the performance implications? What are the correctness implications? All these sort of small things that we have to think about when we design a model. Okay, so how do we go about it? How do we start creating a very simple model that shows something on the screen? The simplest one that we can implement is something called a list. So what we're going to do is very, very simple. We're going to subclass QAbstractListModel, okay? And the mandatory API to get a model done is actually composed by these 2 methods. Only these 2 are pure virtuals in QAbstract at the model. So the first one is something called the row count, which obviously is a way for the view to know how many rows are inside my model. And then the data function, one to actually fetch data out of my model. Okay, so that's pretty much all we need to do. Now, if we also want to use this model in QML, then we also may need to implement this role names function. But I'm going to show that later. I think I got a second slide for that. So let's look at that after we make this one up and running. So I'm going to switch now to code share, to screen share. I'm sorry. See if it works. Okay, I hope. Yes, that's great. Okay, I'm hoping it's working, but I'm going back to my code. Okay, and we're going back to that very code in which I had a list view, and suppose I want to create my custom model for it. So I'm not going to use this QString list model. I'm going to use my own list model. Okay, just to populate a list view. How do we go about it? So, okay, let's expand this and let's get started. As you can see, I'm starting literally from scratch. Okay, I'm not doing, I'm not using any pre-made stuff because I want to really show you what is the typical workflow in creating a model. It's pretty much straightforward work, but still it deserves some attention. So, as I said, a model is an adapter. So we have to figure out what is our data that we are acting upon. Let's say for the purpose of the exercise that we start by exposing the data contained into a string list. Okay, so we have a string list is our data. Okay, and we are simply going to expose it through a model. Okay, how does that work? So again, for the scope of the exercise, I'm going to put a list as a data member of the model. This may or may not be the case. Actually, typically the data is not inside the model. The data is somewhere else, and the model just knows how to access it. Okay, but of course, I'm not actually doing that right here, right now, in the short time that we have. So let's start actually creating this. So I'm just going to give this guy a constructor. Okay, I hope this is straightforward code for all of you. List model parent. And I'm going to populate this list right in the constructor by using some list of strings coming with Qt. One that I love to use are the color names that are available from QColor. So these makes my list contain some data. That's fine. So the setup is done. Let's implement the QAbstractListModel API. So what do I need to implement? As the slide said, there are two functions I need to implement. Let me see if this actually works. Yeah. But there is a little bit of a hint inside Qt Creator. If you right-click on your class definition, you go into Refactor, and there are insert virtual functions of base classes. Yep, that's exactly what I want. And what I want to add, it's already pre-selected. It's the row count and the data, which are the only pure virtuals that I must implement. I'm going to click OK. Voila. And they have been added down here. Row count and data. So this is convenient, so I don't get to type them and make silly mistakes in front of a live audience. And these are the two, really. It's the row count, how many rows have I got, and the data. Fetch the data for each index under a given row. Okay? So I don't like them down here. Let me just move them a little bit up. Right? And let's start implementing them. So we can discuss what's the deal with them. Okay. By the way, I'm sorry, but at the moment I don't see the chat because I'm sharing the screen. So please, again, leave the questions. I will switch back to the chat in a second, and we can, and I can address any questions that you may have. So let's start by row count. How many rows does my model have? Well, I'm supposed to have one row for each element inside my list. So I could just return list.size. Yep, that would work. This is correct, though. am I answering it correctly? Because remember that even this is a list. Look at the signature of row count. Row count takes a parent index. Because what I'm supposed to answer here is a broader question: is how many rows do you have below each possible index inside your model? And all models are trees as far as Qt is concerned. So even though I have a list, it is legally it is a valid question to ask my model. Okay, I understand that you have these many elements, let's say below the root. But if I ask, how about below one of those elements in the list? Does it have children? Well, then the answer cannot be, no, it cannot be 42 or whatever this size is. It must be 0 because I don't have children apart from directly below the root. So even something so simple like returning a correct row count is actually contains a little bit of a trap if you want. You are not supposed to ignore the parent element. You're supposed to honor it by returning the correct information. So what I'm supposed to ask here is this: is the parent that I'm being asked about the root of the list? Because even lists have a root. If this parent is the root, then I'm returning the size of my list, which sits just below the root. If the parent is not the root, so if this parent element is some element inside my list, then I'm returning 0 because my list elements don't have further children. And what is the query? How do I know if the parent is the root? Remember that the query is to ask if the parent is valid or if the parent is not valid. Okay, so if the parent is not valid, then that's the answer. Otherwise, return 0. Okay, this is the correct way to code row count. Okay, so now a view is asking me, okay, give me how many elements you've got. I've got 42 elements. Perfect. Give me the data for element number 3. So in order to give that answer, I need to implement this function. Okay. So how do I know which index? I mean, I don't know something about the index that I'm passing. Remember that an index remembers its row, its column, its position in the model. So from the index, I can know which element of my data of the list I am referring it to. Yep, I can actually extract it right away by saying index.row. I don't really care about the column because I only have one column. I'm a list, right? And then all I need to do is extract the list at that position. So I'm really using straightforward coding here. I'm going to call this like result or whatever, which is list at row. Yep, and then I return this result. Yep. So if I build this builds eventually. No, it doesn't. Oh, I'm sorry. What did I do? Here we go with live coding. Oh, sorry. Yeah, this Qt creator being a bit too gallant and adding definitions out of class that I didn't need. Okay, that's fine. It's complaining that I'm ignoring the role. Well, yeah, that is something to keep an eye on. But this is it, really. It built. So this was the API that I needed to implement. Now what I'm going to do is to take this list model, create an instance down here, line 58, okay, and use it as a model inside my list view. Okay, so I'm setting it as a model right here, and I'm showing the list view. I'm ignoring Qt Quick for the moment. So let's see what happens when I run this. A nice empty list. What is going wrong here? What I'm doing wrong? Well, remember the warning, you are ignoring the role. Yeah, I should not actually be ignoring the role. Why is that? Because the built-in delegate inside a QList view asks different kind of data in order to draw each line of my list view. Okay, and it asks different things under different roles. And I am supposed to not ignore the role, but return the right thing depending on the role that I'm being asked. So the delegate may ask, okay, what's the string that I need to represent, that I need to use to draw your element? And string, so these are color names, it's the color blue. Okay, the string, I need to draw the string blue. And then he asks, okay, what kind of icon do you want? And by using a different role, so by using a decoration role. And my code is returning blue as a string. Okay, the delegate is now slightly confused. What kind of font should I use to draw your element? And I'm returning the font is called blue. You see where this is going? You know, by ignoring the role, I'm starting to return garbage to the delegate, which gets super confused and eventually draws nothing on the screen. So I'm not supposed to do that. So I'm not supposed to ignore the role. Okay, I'm supposed to handle the role correctly. But what I want to do here is to handle at least one role correctly, the so-called display role. For the display role, I'm supposed to return a string, and the string is the string visualized by the view. And I can then ignore any other role for the moment being by returning an empty variant. And that means my model does not understand, does not handle that particular role. So what code looks like here, I'm just going for the simplest approach. So if the role is not the display role, just return an empty covariant. Okay, I don't handle anything but the display role. More in general, you could think of this as a switch statement, right, on the different roles that you may want to handle. Oops, yeah, thank you, compiler. Saved me from a silly mistake there. Okay, now it builds, and if I run it, okay, now we're up and running. Now I got my list of colors, okay, which is being fed from my model. Okay, so more in general, you may want this not to be just an if, but you may want this to be a switch over different kind of roles that you want to handle, and for each possibility, you return the right thing. So let's make this already a little bit more, if you want, fancy or complex. Let's also handle the decoration role, which is the icon that should appear next to each element in my list. Okay, so let's turn this into something better. For instance, yeah, I can do this, which is, if you want, common code, and then I put a switch on the role. Okay, so if it's the display role, then just return result. Okay. Otherwise, if it's the decoration role, then for the decoration, we can return different things. We can return an icon, we can return a color or something like that. Let's return a color. And since my string is a color name, I can actually just return that's a Q color from the result. Okay, and sorry. Okay, so I just decide what to do depending on the role asked. This returns a string. This returns a color. Otherwise, return covariant. Okay, if I don't know the role, I don't know how to handle it. Sorry, I cannot give you any data out of this. Run it, and now it looks even fancier. Look at that. Okay, now for each element, there is a little square. That's what the QList view default delegate gives to me, right? And it's able to handle the two different roles that I'm returning. Yep, by having a little color in there. Wow. Okay, so that was relatively simple, wasn't it? Except for these little things that you must pay attention to. I'll switch quickly on the chat if there are any questions, but I don't see any. Yeah, thank you. I knew about that. Oh, I didn't know about that. The compiler knew about that. I'm happy about it. Okay, so back to the code. Off we go, and let's see something else about this. So let me take this working model and let me also expose it to QML to make it possible to use this model from the QML side. Now, there is something peculiar about QML, which is this. In QML, when you write a view and you write a delegate inside the view, the delegate accesses the data in the model, but you don't specify roles as numbers or as enumerations because they don't kind of exist in QML. Well, they do, but they're different. In QML, you don't pass the roles as enumerations. In QML, you just use strings. You use, technically speaking, property names to figure out which role you want. Okay. So if I open the QML code, yep. So this is my view in QML. Okay, that's my list view. It's populated by the same model that I just created in C++. And if I look inside my delegate, I use these strings to fetch data out of the model. Okay, so I use this property called display, or I use this property called index, or maybe some other property that I may acquire the property, whatever, property string foobar. Okay, so you come up with these names. And how do these names reach the model? They don't reach the model directly because the model, the data function, does not get a property name as input. What happens is that there is a mapping between the property names that you use in QML and the integers that we use in C++ to represent the roles. This mapping is implemented. There is a default mapping in Qt. Okay, but there is also a possibility to customize this mapping so that you can use any property name you want in QML. Okay, you just synchronize with the designer. The designer tells you, I'm going to use these property names. And in C++, you define the mapping from the property names to actual integers that we have in C++. Okay, to give you an idea, so this is implemented in C++ by implementing the another virtual, which is called role names. I'm going to use the same shortcut to avoid making mistakes. Insert virtuals, and the one I want is called role names. This one. All right. Sorry, moving it up again. Okay, here we go. Here we go. Let's look at this function. What does this function do? This function returns a hash, so some sort of associative data structure that maps integers, which are roles, to strings, which are the property names used in QML. So if I want to map the things that I was using QML to some of my integer data roles, I need to define this mapping. Okay, I need to create in here a QHash int QByte array mapping and insert things as needed. So the mapping for Qt display role is called display. That's the name of the property QML, and that's the role that my data function is going to get. And I keep populating it as needed. So mapping to whatever that is called foobar. Okay, and you keep populating it as needed, and then you return the mapping. Okay, by doing this, we are actually defining how the view in QML fetches data out of the model. Okay, so we are defining pretty much what these things in QML use to fetch the data out of the model. Index is a special one. Index is built-in. You don't need to provide it. It's going to be the index of the number inside the index of each delegate. So when created by the view, so this is built-in. But for display or for foobar or for any other kind of property that I use in QML, I need to define this mapping. Now, luckily for me, there is a built-in mapping. So if I quickly open the role names documentation in QAbstract data model. Zoom in a little bit. Yep. As you can see, there is a default mapping predefined by Qt. Okay, so things like the display role is already mapped to the display name, decoration role to decoration, and so on and so forth. But this may not be enough. You may need to extend this as needed. And you do that by overriding this function. Okay, and once you do that, once we override this role name, and now we build, actually, I enabled Qt Quick again. Did I do something wrong? I don't remember. Okay, and I run it. Here we go. Now I got the model in C++, just as before, in a QList view, and the same model in a list view in QML. Okay. All right. Is there some? Let me check if there are any questions coming up. Not yet. Okay, I can keep. Sorry about this holo mirrors effect. It's what happens when you share the screen and also share the same window. Okay, so let's see a few other things regarding this model construction here. Okay, there are a few other things that you may want to keep an eye on when you build such a model. So get rid of this. So the first thing is this. Notice how I am getting the row here, and then using it to access the list, and I'm not doing any bounds checking. Right? I'm not even checking if this row is negative or if it's out of bounds or not. I'm just trusting the index to be correct. Is this right? Is this good? Is it bad? You may have different opinions regarding this. I'm just going to tell you that the data function itself does not expect the index to be out of bounds or anything like that. Okay? You are supposed to pass just valid indexes inside this function. You're not supposed to pass garbage. However, maybe you get a little bit of a paranoia mode, so you may want to actually double check or triple check that everything is fine, that no one is passing you, whatever, the invalid index, right? The one pointing to the root of the model, because that one does not have data. Or maybe someone made the mistake of storing a model index for a period of time, then the model changed, and then it's using it to access your model. Or maybe there is even a simpler mistake. Maybe you get an index from model A, and you use it to access model B. Of course, that makes no sense, but technically the code compiles. So how can you make sure that this index is correct? If you want to be really defensive, you have to start checking lots and lots of things. So you need to start checking, get the row. Okay, now, if the row is less than 0, or the row is bigger or equals than the list size, then it's not good, right? Return equivalent. And am I sure that this index is in column, as actually column 0? No, I need to check. So if index column is different from 0, then it's not good. Get out of here, right? And so forth, so forth. If the index is not valid or whatever, well, this is kind of implied, but I don't want. And if the index model is different from this, oh, sorry. Okay, here we go. If the model of the index is not me, so this means that someone got an index from some other model and it's using it inside here. That's a problem. I don't want to handle that. Okay. Right. So there are a couple of things here. The first is that remembering of doing all these checks is well, a lot. Okay. Then you may not want to pay for these in production. Maybe you want to turn these into like assertions. So you check these in debug mode, but ignore them in release mode. Okay, there are different philosophies that you may want to use to tackle this problem. But whatever is your philosophy, that is ignoring, debug only, soft assert, hard assert, you name it, I'm sure that you don't want to write all these checks every single time you implement data. Or any other model function, really, because when you start being paranoid, I mean, yeah, this is a set of value checks for data. What about row count? Should I check the same? Probably you should check the same also in row count. Okay, so Qt offers you a little bit of help to avoid doing all these checks on your own. There is a helper function that I have personally added a little time ago in Qt, which is called check index. Okay. You can call check index, passing an index, plus some other option. In this case, I want that the index is valid, and this check index runs these checks for me. Okay, so it does some checks. I don't need to do them myself. And check index returns a Boolean. So I can then decide what is my strategy of dealing with the mistakes. You could leave it as an if. So if check index fails, then I just return covariant. Or maybe you print a warning message or whatever, really. Or maybe you want this to be an assert. So you don't pay for this at runtime, in production builds. You decide, okay? But this is definitely the helper that you want to use to be a little bit defensive in your programming, okay? To allow for some room for mistakes, that you can catch the mistakes before they become fatal, right? So I can build with this. Hopefully it still builds, and you can run with this. Yep, and everything is fine. Okay. Okay, sounds good. Okay. What else is there to say about data? There is something else to say about data. Okay, let me show what I mean by that. So this is my model. It's visualized inside this list view. There are like, I don't know, 3, 4, 5, 6, 7, 8, I don't know, 10 entries visible at any given time. So with 10 entries visible at any given time, okay, how many calls to the data function of my model do you believe the view issues? Is it 10 calls? Is it 20? Well, you know already that each index is asked at least twice, one for the decoration role and one for the display role. But how many? Well, let's find out. There's a very quick thing we can do, which is just use a debug print. Okay, I'm going to use something like a static int counter. And then I'm going to call number plus counter for index and row. Yep, I'm just giving you a little bit, a little helper here, just a small static counter to understand how many calls are placed to a data function by a view. I don't know if anyone attempted an answer in the chat. Okay, there is a question. I will answer that question in a second. But so if you are thinking there are 10 visible elements, I'm going to have some like 100 or 200. Where is the output? You were way off. Way off. Let's look at the numbers down here. Just by showing it a couple of times, I already given 1,000 or 2,000 calls. Yep. And it takes nothing for these calls to go up in the dozens of thousands. Yep. So there is a little bit of truth here, which is this. Views don't cache anything. Views will hammer your model to fetch every single piece of data they need. Okay. Indeed, when you look at what this guy is doing, it's just requesting some data from the model. Really, it's not doing anything special. Okay, so it's requesting different roles for row 7, column 0 of my list model. Row 7, column 0 of my list model. Okay, and you can see the role is changing, so it's requesting different roles. It's only requesting a tiny subset of rows, because I can only see the first 10 or so. So it's only requesting data about those. But still, the view is asking a lot. Okay, it's asking everything it needs to the model. The view or the delegate does not actually cache anything. It's not their job. So your data function, as a corollary, needs to be fast as it can, to provide data to the view. Please don't do something like that every call inside data, you open a file on disk, you search for the data you need, and you close the file. Or if you have to issue some, like, whatever, request to some server, you do a request every time data is called. I've seen that done, and of course the results are disastrous. You don't want to do that. All right. If there is any caching that needs to be done because your actual data layer is low, the caching becomes responsibility of the model to do. You're not supposed to do it in the view or in the delegate, because it's not their job. It's the job of the model or some level below the model. Okay, this is just to give you an idea of how data actually functions. So there was a question in chat, which was, is role names called every time or once and for all? It is called once for all. Okay, it's called it's called once when you create when you place a model into a view, and there is also a notification signal that you may emit, which is called a model reset, to tell a view that to forget about your model, to like restart from scratch, and that includes fetching again the role names. Okay. But otherwise, once the mapping is done, once the view has fetched the mapping, that's it. It's set in stone if you want. To be honest, I never had the need to change the mapping dynamically as I go. Typically, that doesn't happen. Once you have a view and a delegate that expects certain roles, those roles are already provided by the model, and there isn't any need to change them as you go. But you never know. Maybe you have some use case for that. Okay, all right. And let me actually add something extra regarding this idea of building a robust, solid model. There are another couple of things that you may want to do once you have a model, and maybe there is a mistake. Maybe you don't see what you expected to see. Okay. For instance, remember the first thing that we implemented. We ignored the role and just said return result. Okay, that was a mistake. I was running this, and nothing at all appeared on my screen. Yep. So how do I, for instance, debug a situation like this? There are a couple of possibilities that you should be aware of. The first one, I cannot praise it enough, is of course using gamma ray on your application. If you launch gamma ray, and if you want to know what this is, I gave a talk about gamma ray a couple of years back at this very conference. So check out the video, and you attach gamma ray on my application. Between the things that gamma ray is able to show regarding your application, there is this little tab right there, which is called models. You can click on it. Yep. And you can select the model, and this shows that the model is returning garbage. In particular, it shows you that you're returning a string for each role. So what is the string to show? It's Alice Blue, okay. And what is the tooltip? Alice Blue, okay. And what is the font? Alice Blue, wait, what? And what is the size that should draw this unit in? It's Alice Blue. Okay, now I'm confused. I don't want to do that anymore. And that's the reason why we get an empty screen. Okay, so this allows us to figure out what is actually going on. So the models tab allows us to inspect the content of models inside your application. Thank you. Okay, so please you have that as a little ace up your sleeve. There is also another thing that you may want to use, which is a small helper class, which is called QAbstractItemModelTester. This helper class is something which is part of QTestLib, and is something that you may want to keep around while you develop a model. Okay, the point of this class is very, very simple. You just create one. Where's it? Here. And you make it point to your model. Okay, so look at what I did. I just created a tester object, told it, okay, this is your model, and that's it. And the point of this tester object is to stress test, if you want, to check your model for any kind of flaws that you may have when you develop your model, such as ignoring over here the returning inconsistent row counts, something like that, returning the wrong data type for a given role, okay? All these sorts of checks. It basically keeps an eye on your model, and every time your model misbehaves, the tester will report something on your console, or if you want, it may also decide to crash your app. There are a couple of options that allow you to, for instance, run your app into a debugger with this tester active. And if your model misbehaves, the tester will make your app crash, but you are in a debugger session, so you can backtrack and figure out, why is my model reporting something inconsistent? So all you need to do really is to create an object, leave it around, and that's it. You don't need to do anything with it. It will report if something goes wrong. So thankfully, it's not reporting anything. Okay, my model is well behaved, but if I start doing something stupid, as I'm going to do in a second, then this tester will start to complain loudly. Okay, I don't know if I can quickly make it complain loudly by redoing the same mistake once more. Usually it doesn't, but what is the deal with my computer? I think screen sharing is killing my CPU. Now, okay, it's still not kind of complaining about this. We'll see it in a second, however. So, QAbstract model tester, keep it around while you develop. And then, again, in production, just remove this line or protect it by if-defs, whatever you want to make it, to not make it raise warnings in production. Any more questions? Where can you get the old talk on gamma ray? Okay, I will post the link as soon as we're over, I guess. But it's if you look on YouTube and Google for QtDay, my name, gamma ray, you will find it. And does check index add overhead in production code? Can I select different options? So it adds the same overhead of doing the checks yourself. What it does is that it really runs the index through this series of checks, like is it in range? Does it belong to myself or to some other model? So it is a little bit of overhead. Whether that overhead is acceptable to you or not, run into a profiler. We're talking nanoseconds likely, okay, or microseconds. But if you have a model which is really a bottleneck, then you may not want to pay for those checks in the first place, because you're not supposed to pay for those checks. Okay, the API of QAbstract data model is a strict API, it's a narrow API. You're not supposed to pass garbage in, garbage out. Check index is mostly useful as a debugging helper or debugging aid, in my view. But you can definitely leave it in production code, and it's unlikely you will see a massive performance hit unless you're really hammering your model billions of times per second, something like that. And yes, you can select slightly different options, depending on, not all the checks make sense all the time. So if you open the documentation, there is a little bit of discussion about what kind of checks you may request from check index. It's there, yes. Okay, I hope I answered the questions. All right. So I'm quickly going back to my presentation just to see that we have discussed this. We have discussed role names, and we've done a little bit of a demo about what we can do and how we create a model, how to make it robust, and how we debug the model in case something goes wrong. Okay. Yep. Also this, and this. Now, let's also do something else. That is, let's make our model modifiable somehow. Okay, I may want to decide that my model is not read-only as it is at the moment, but I may want to let the views or the delegate edit the data in my model. How do I do that? So to do that, there is something very simple that I need to do. I need to implement additionally 2 extra functions. Okay, these 2 extra functions are called flags and setData, and these are the ways that a view is going to modify the data inside my model. There is also something that must be said here. That is, this is the API which is, if you want, the API that the views talk. But nobody stops you from providing your own model-specific ways to set data. Right? If it makes sense for the rest of the application, for the rest of the business logic that you have, to also have some other way to change data inside your model, by all means, add extra functions. The only caveat is that the built-in views and delegates don't know about it. You need to either use a custom delegate or do something else to make them use your model-specific way. The only way that the built-in views and delegates know about are these 2 functions right here. Okay. And now, once you modify something, you also need to tell the view to refresh itself, or to tell other views, I'm using 1 model and 2 views. You may decide to have 1 view modify the model, and the other view has to change. So how do we go about that? We need to emit a signal. We need to emit a notification signal. This notification signal is called data changed to notify the views. So let's do that. Let me share the screen again. And let's see how do we create a modifiable, oh, what did I do? Okay, a modifiable model. So everything stays the same, but I need to implement something extra now. The first thing I need to implement, sorry, I'm going to use the shortcut again so I don't do any mistake, is to implement this function called flags, yep, and also setData, these 2. Okay, there we go. I don't know why Creator has this tendency of adding stuff to the bottom. I'm going to put it over here so they stay close to everyone else, and we can start. Okay, let's start from the second one, flags. What is this about? For each index of a model, you can provide an additional set of flags that describe what a view can do with that particular index. So these flags are things like the item can be selected, or the item should appear enabled or disabled, or the item can be modified. You know, the usual drill if you want. Okay, so you can provide this if you want a bit mask of flags, and by default, elements are not modifiable. By default, elements are selectable, I believe, and enabled. But you can decide index by index what you want to do. So you may want to allow some elements to be enabled, some elements to be disabled, some elements not to be selectable, anything you want, really. Okay. So I need to pretty much, what I need to do here is to add the possibility of modification to my elements. So what I'm going to do here, very lazily, I'm going to return the same flags that QAbstractList model. Where is it? Here. Flags. Things are true for a given index, and I'm going to or QtItem is editable. Yeah. Okay. I'm going to be very quick, very lazy, but simply going to bitwise or the possibility of elements to be edited through a view. Okay. Once a view sees this, they may decide. They may allow editing to happen on a particular index. Okay, I'm just returning it for all the indices. I don't care. And how does the editing actually happen? The editing happens by calling the setData function. So the views, the delegates are going to call setData to set a new value, this value here, on a given index, this index here. And again, you may decide to edit one specific role of your view. The default role that gets edited by something like a QList view is called the edit role, but that's up to you. You may decide to have a custom delegate that decides to edit another role, whatever. Now, the setData, what is its responsibility is to go to the actual data, do the editing, Now, the editing may fail or may succeed. If it fails, you just return false, and the view knows that the editing failed. If the editing succeeds, you return true. But if the editing succeeds, you are also responsible to emit the notification signal telling other views, telling everyone, hey, my data has changed. Okay. So the way we do that is it's pretty simple. I'm going once more to just extract the row. Okay. Just for a practical reason, I'm going to do any checks whatsoever here, but you may want to add the checks. Okay, so what I need to do here is to modify the list at position row and set it value as a string. And now I'm going to accept the modification, so return true. But before I do that, I need to notify everyone that this specific row has changed. And I do that by emitting the data changed signal. Okay, this is the signal that notifies something has changed inside the model. Update. Okay, and this signal actually has two parameters, or three parameters, should I say. These parameters pretty much describe the region of my model that has changed. Okay, you can pass a range of indexes that has changed, not just one index. Now, in my case, just the one index has changed, so I'm just going to pass index. So I got a range of size 1, it's the index, but in principle, this could be a range of indexes that has changed altogether. Okay. So if I didn't do any mistakes, I can build this now. Oops, yeah, sorry, again, the role. Yes, you're supposed to check if the role is correct. So if the role is not the QtEdit role, that just return false, because I don't know to edit anything but the edit role. And if I manage to build this, and we can go. Okay, so this is my list, just like before. Now I should be able to double click on element, and here we go. I'm able to edit it and set to hello. And now it says hello. Or I change it to something else like blue, and it changes. Hello, QtDay. Yep, that's pretty neat. And to double check that this actually is working as intended, well, let me bring back the Qt Quick UI. Please build quickly. Okay, here we go. So now I've got both two views on the same model. I can go here, change this to hello. And notice that it changed also in the other model, right? Yep, so the two models are are the same model. They're not two models. The two views are using the same model. And once I modify one model, the model through this view, I'm emitting the right notification signals. So the other view picks them up and updates the data at those positions. Okay. So everything is fine, and this is how you're supposed to do it. So what is this edit role? This edit role is simply the role that gets normally used for modifications, because maybe you want to make your data appear on the screen in a certain way, and then when the user requests editing, you may want to make it appear in a different way. Okay, maybe you have, I don't know, you're showcasing some numbers, and when you're showing them, you want to use all the fancy decimal separator and multiple of 1,000 separators and whatnot. But then when the user wants to edit it, you just want to show the number without any fancy string decoration. So you may return two different things. You may handle the display role as a fancy formatted string, and the edit role as a number. And that's why you have these two different roles when it comes to data and set data. Even in data, we can also actually return in data, we can return the same string as the edit role, so that when I start editing, the editor already contains the string that I want to edit as that string. So when I start editing this one, as you can see, it's proposing me to edit the string antique white and change that to blue. Okay? So this is how we implement editing. Let me see if there are any questions. Can I use the reset model to notify that all the data has changed? In principle, yes, but there is something different between changing the data and resetting the model. They are two semantically different operations. So if you change the data, that means the structure of the model is the same. Okay, the data has changed inside the model. If you use reset model, you're telling me that everything about the model has changed. So you may have changed also the number of rows, the number of columns. Everything has to be fetched again. A view will likely lose its scrolling position if you reset the model, because it's like if you are setting a brand new model for the view. So use that as a last resort to really mean the model has been resetted. Don't use it as a shortcut instead of emitting the right notification signal, because this will backfire. Okay. And okay, let me go back here. So this is how we handle modification of the data. And I got one last thing, which is how do we handle modification of the structure? Well, sometimes I'm not modifying the data as is. I'm not changing the contents of the model. I'm just changing the model structure itself. Maybe I'm adding rows, or I'm removing rows, adding columns, removing columns, whatever. Okay, so this kind of changes must also be notified to the views. Okay, and how these changes happen? Okay, they can happen through the public API. They can happen through your own model-specific ways. It doesn't matter. The important thing is that you notify the consumers, the views, that your model has changed. What is tricky about structural modifications is that Qt models have a notification approach which is transactional. What do I mean by that? I mean this. Suppose that you have your model and you want to tell the views that you have inserted the new rows. Okay, how do you do that? Well, you do it like this. You call begin insert rows to tell the views, I am about to insert the rows. I have not inserted anything yet. Okay, I'm about to. Then you actually insert the rows. Okay, and once you're done, you call end insert rows. You don't emit any signal on your own. Qt will emit the right signals for you in the right order with the right parameters. But you must pretty much wrap every critical section in which you modify the structure of your model by these begin end pairs of functions. And of course, this is for inserting rows, the same identical story for columns and the removal and resetting of models. Okay, they're all transactional. So how do we do that? Suppose that I want my model to have new rows at the beginning. Okay, so I want to add a couple of new rows to inside my model, and I want, of course, my views to be notified about that. So for that, I'm just going to add a custom method of mine. I'm going to call it add rows, whatever. Okay, and what I'm going to do here is this. So suppose I want to add one row at the beginning of the model. Before I do anything at all, I begin the transaction, if you want. Okay, so I call begin insert rows. And begin insert rows wants to know where you're adding the rows. So it wants to know the parent index. In my case, I'm adding them just below the root. So it's QModelindex. Where you're adding them, that's the second parameter, and how many. Okay, so I'm adding them below index number 0. Okay, and the third parameter is not actually how many. It's not a count. It's what is the last number in the range that you want to add. To better understand these two parameters, I definitely recommend to open the documentation of begin insert rows, which is right here. Yeah. And there's this very nice picture that shows you what these parameters mean. So suppose that you have this list that goes 0, 1, 2, 3, 4, 5, and you want to add these 3 elements in the middle. Okay? You're supposed to say that you're inserting before the old position 2, and the last one you're going to add is going to be at position 4. So this is the meaning of these parameters. Okay? If you add at the end, you're going to add before position 4, and the last one is going to be position 5. And that's why you call begin insert rows 4 or 5. Don't worry too much about this, because I still get this one wrong. Refer to the documentation every time you manipulate this, or draw a small diagram and understand what is the numbering. It's a little bit tricky, but as anything that expresses ranges, the opportunity of a off by 1 is always there. So yeah, I'm going to just insert something at the very beginning. Okay. And before doing this, I don't touch anything. Then I'm actually going to insert something in my list. I'm going to insert something at position 0, hello QtDay, and then I'm going to call end insert rows. Okay.
Giuseppe, so sorry to interrupt. No. I don't think you are sharing your screen.
I'm so sorry. I'm terribly sorry. This is what happens when I have to switch back and forth.
No problem. Thank you.
I'm so terribly sorry. Sorry, everyone. Thank you for noticing or not noticing. Okay, here we go again. Okay, so what I want to show is this. Quick recap. I went into my model, and I used this void add rows function as a custom function to insert rows into my model. Okay, as we were discussing, add rows, rows insertion or removal or any that kind of structural modifications are transactional. You're supposed to call begin and end. Okay, and wrap your modifications between these two. Right. Now, begin insert rows says, I want to add the rows, and you need to tell where you want to add and how many. So I want to add the rows below the root, starting from index 0 and ending at the index 0. This means I'm adding 1 row just below the root, just after the root. Then I'm actually doing that. I'm modifying my data storage, okay? And then I'm saying, okay, I'm done. Yep. And this is all I need to do to implement some sort of modification of my model. So what I can do now is, for instance, have a timer trigger and add a row to my model. Timer start like 1 second, and connect my timer. Keep timeout to my list model. Add row. Okay, does that work? Oh, what did I do now? Let's go. Add rows. Yeah, no, sorry, add row. It's just one that I'm adding. Okay, and eventually this builds. Why is it so slow today? Okay. And as you can see, the model is being modified by a mysterious god, which keeps inserting rows at the beginning. Yep, but it's actually working, right? So as you can see, a new row is getting added at the beginning every second. Let me actually show that these rows are all different. So wherever counter is 0, and this is string, hello QtDay number. Eventually this builds, and we're good to go. Okay. Yep. As you may notice, this model is being modified structurally. I'm adding new rows into the model at any position I want. Okay. Yep. As you can see, the views are scrolling automatically to keep dealing with the fact that my model is adding more data. Okay. Everything is good, right? Yep, sounds good. Okay. So let me see if there are any questions. Sorry about the little hiccup in terms of going back and forth or sharing code, sharing screen. Are there any questions so far? Okay, it does not look like it. Okay, because otherwise I think I'm done, pretty much right on time. I have some bonus slides that of course I'm going to leave to the attendees. How do we extend this? So how do we go like to tables or to something, to trees? Now you should know enough to go there. Okay, a table handle also the columns. That's the idea. Okay, we handled the rows so far because it was a list. For a table, we also handle columns. Okay. That's pretty much it. Trees are slightly more complex. For trees, you may require a little bit of understanding, but you should have all the things you need now to handle trees as well. And you can build on top of this. There are more complicated structures like proxy models and other fancy stuff coming from Qt, from KD Toolbox, from K-item models. By all means, use all of those if you want to build complicated models or complicated model stacks. This is the bread and butter of model making. So I think, yeah, right on time. It's 10 past the hour. Are there any questions? Let me scroll up a little bit in the chat. Let me see if I have got something missing here. Okay, it's a comment, I think. The part that is not really well documented is the handling of the layout changes and how to properly handle the persistent model index. That is absolutely right. That is probably the most advanced topic coming from to discuss in terms of model view. I don't have the time to go through that kind of functionality right now, but what I would suggest you to do is that if you get to that point, I would suggest you to read the source code of some class that implements layout changes. And to understand, there's usually a fair amount of comments left by the authors that had to go through the trouble of understanding the semantics of that. And so they left the comments in the code saying, I'm implementing layout changed, and these are the semantics that I expect. Okay. So yeah, it's really a tremendously advanced topic. It's probably one of the most advanced topics that you may handle when you're dealing with models. Don't worry too much. That's definitely not something you do every single day. Okay. So yeah. Is there something else? Some other question? You are very welcome. I would like to take this moment, this opportunity to thank the QtDay organizers once more for having us every year. Of course, the virtual conference is not as the same as being in Florence in spring, drinking wine during the lunch breaks. Maybe that's something for next year, crossing fingers. But anyhow, thank you very, very much to all the organizers. I won't do any names because I will forget somebody. So thank to Develer for organizing this.
Absolutely. And thank you for your contribution as well. Let's cross our fingers that next year we could do it in person.
Yep, definitely.
All right. Well, thank you so much. And if that's it, if we have all the questions, then we can take a bit before the next workshop that we have at 2:30.
Right. I'm available. So if you Google my name, you will also find my email address. Send questions this way offline. By all means, do that when you watch this talk, even later on YouTube. Please don't leave comments on YouTube and then nobody watches them and replies to them. Write to me. I can reply. Okay.
Excellent. Thank you. Oh, and I just want to remind all of the participants that if you enjoyed the workshop, you can actually rate it on the agenda page of Bizzabo. So we always appreciate feedback, for sure.
Yeah. Please, thank you.
Oh, yeah, and everyone's asking for the slides as well.
I'm sure. I will give them to organizers. I'm not exactly sure how they will get shared to everybody. Probably on Bizzabo, I guess.
I think we can arrange something.
Yeah, we will leave a link somewhere.
We'll find some way to do it, definitely. All right. Well, I'll leave you to it. I hope you enjoy the rest of your day, Giuseppe, and thanks also to all the participants as well.
Thank you very much.
All right. We'll see you next time.
See you next time. Bye-bye.
Definitely. Bye-bye. All right, everyone. That concludes this workshop. We'll be back here at 2:30 p.m. Italian time, which is in about an hour and 15 minutes for our next workshop, which is Create User Interfaces with Qt on Raspberry Pi with Luca Ottaviano. So hope to see you then. Thank you. Bye-bye.